Welcome again to Math 800 Pre-Algebra. Today we are doing section 6.4, Problem Solving with Proportions. Our objectives: to use proportions to solve application problems. Our first example: Mike's car can travel 163 miles on 6.4 gallons of gas. How far can it travel on a full tank of gas, of 14 gallons of gas? Round your answer to the nearest mile. Notice that we are comparing different units. We know that we have 163 miles on 6.4 gallons of gas. And then how far? How far is always asking questions such as miles, feet, meters, kilometers, etc. Can it travel on a full tank of 14 gallons? So we are comparing miles and gallons. In this case, our proportion is going to be comparing two rates because they have different units. Your first step is to read the problem to understand it. The most important things are to identify what is known and what is unknown. Unknown are the number of miles traveled on 14 gallons of gas. Known is that 163 miles were traveled on 6.4 gallons of gas. The next step is to assign a variable to what you don't know. We don't know the number of miles traveled on 14 gallons of gas, so we will let x represent that value. Now we will set up our proportion. Before you set up your proportion, it's important to decide what is being compared. In this case, we were only given a few numbers, but sometimes you'll be given problems with several numbers that aren't used. So it's very important to figure out what two things are being compared in your rates or your ratios. So in this case, we are comparing miles to gallons. We need to make sure that our rates are set up the same way so that the units in the top or the numerator are the same for both and the units in the denominator are the same for both. Our first rate is 163 miles to 6.4 gallons. We have miles in the numerator and gallons in the denominator. We must match that in our second rate. So we have x miles over 14 gallons. Again, notice in both cases the units match. That is very, very important. If you have one of your rates flipped so that the units are in the wrong spot, you will not get the correct answer. When you're saying that two things are equal, you have to be comparing in the same order. It's the equal sign that insists that these have to have the same units in the numerators and denominators. Now we will solve this proportion. Again, we are going to use my method, which is to multiply both sides by a common factor, common denominator, that involves both the denominators, and then canceling out the common factors. So in this case, the common denominator we will be using is 6.4 times 14. I'm going to multiply both the left side and the right side of our proportion by that. Cancel out the common factor on the left, which is 6.4, and on the right, which is 14. Multiply 14 times 163 is 2,282, and x times 6.4 is simply 6.4x. Notice at this stage I've dropped the units. You need the units in the beginning to make sure your proportion is set up correctly, but once you have it set up correctly, you can ignore the units until the end when you put it back in your answer. Now I will solve this by dividing both sides by 6.4, and I get 356.5625 equals x. I will admit this is slightly difficult long division. I don't expect you to do any long division past this, particularly in this case because the problem told us to round to the nearest mile. So really all you needed was something in the tens place so that you could round to the nearest mile. In this case it would round to 357. So, state our answer. Mike's car can travel 357 miles, which is rounded to the nearest mile, on a full tank of gas. We should always check to see if this is a reasonable answer. The car traveled 163 miles on 6.4 gallons of gas. 14 gallons is a little more than twice 6.4, so it's a little more, about twice as much gas, so you should travel about twice as far. 163 times 2 would be 326, so our answer of 357 is a little bit more than 326, therefore it is reasonable. Obviously, we can't guarantee we didn't make a minor mistake or that we rounded incorrectly, but it lets you know if you're in the right ballpark. Therefore, our final answer is that Mike's car can travel 357 miles on a full tank of gas. A second example. A newspaper report says that 7 out of 10 people surveyed watch the news on TV. At that rate, how many of the 3,200 people in town would you expect to watch the news? So let's identify our unknown and our known. Our unknown are how many people out of the 3,200 in town are expected to watch the news on TV. What is known is that in a smaller survey, 7 out of 10 people watch the news on TV. So we will let X be the number of people in town who watch the news on TV, since that is our unknown. When we're writing our proportion, we have to, again, note what we're comparing. In this case, we're comparing the people who watch the news to a total population, either the total population in the survey or the total population in the town. So we're comparing the people who watch the news, which was 7 out of our smaller group and an unknown number out of our total, to the total number. So the total in the group of the surveyed was 10, and the total in the town is 3,200. Notice how I didn't bother with putting the units people, because both the top and the bottom had the same units. It was people compared to people, so that wasn't helpful. Sometimes you might put these labels within the ratio. So you might say 7 people watch the news, and then 10 people total, and then X people watch news out of 3,200 people total. That's fine too. And the important thing is that whatever is in the numerator in the first rate or ratio is the same thing in the numerator in the second rate or ratio. Now we will solve this proportion. We will multiply both sides by the common denominator of 10 times 3,200. I'm multiplying on both the left side and the right side of this equal sign. Again, that is the very basis of algebra, that you can do whatever you want as long as you do it to both sides. On the left, we cancel out the 10s. On the right, we cancel out the 3,200s. 3,200 times 7 winds up being 22,400, and x times 10 is 10. Divide both sides by 10, and we get 2,240 equals x. Therefore, we would expect 2,240 people in town to watch the news on TV. If we check this, 7 out of 10 people is more than half, but it's less than all. So half of the people would have been 3,000. Half of the 3,200 would be 1,600. So our answer should be between 1,600 and 3,200. Our answer of 2,240 falls in this range, so it is a reasonable answer. Again, this doesn't guarantee that you didn't make an arithmetic error somewhere, but if you had your proportion set up incorrectly, this would catch that mistake. So our final answer is that you would expect 2,240 people in the town to watch the news on TV. Our third example. Brian is planting new grass for his yard. To keep the seeds from being eaten, he covers the seeds with black plastic. One piece of plastic covers an area of 80 square feet and costs $14. How much will it cost Brian to cover his total yard if it is 700 square feet? So if we read the problem, our unknown is the total cost for covering the 700 square feet. The known would be covering 80 square feet costs $14. When we set up our variable, it will be x for the cost of covering the 700 feet squared, since that was our unknown. When we set up our proportion, we are comparing the amount of square feet covered to the cost. Again, it doesn't really matter which one of these, square feet versus cost, is in the numerator or denominator as long as you are consistent. So if you put square feet in the numerator for your first rate, you need to put square feet in the numerator for the second rate. And if you put cost in the numerator for the first rate, then you need to put cost in the numerator for the second rate. The key is consistency. In this case, I'm choosing to put the square feet in the numerator and the dollars or cost in the denominator. So my numerators are the square feet covered. On the left, I have that smaller area. On the right, I have the whole yard. And then my denominators are the cost. Again, on the left, it's the cost for that smaller area. On the right would be the cost for the whole yard. Notice how I have matching units in the numerator and matching units in the denominator. This time I included the units because they were different, since we're working with rates. Now we will solve this proportion. Multiply both sides by the common denominator of 14x. So 14 times x on both the left and the right side. On the left side, the 14's cancel. On the right side, the x's cancel. X times 80 is 80x. 700 times 14 is 9,800. Solve this by dividing both sides by 80, and we get x is 112.5. In all cases, round your money to the nearest cent. In this case, we didn't have to do any rounding since it terminated at the nearest dime. So we would say that it will cost Brian $112.50 to cover his entire yard with the black plastic. To check this, note that 9 times 80 feet squared would be 720 square feet. That's a little bit more than what we want of 700. So therefore, 9 times $14 should be a little more than our cost for the 700 square feet. 9 times 14 is 126, and 112.50 is close to, but less than that. So therefore, our answer of $112.50 is reasonable. Last example. The DNR is trying to estimate how many deer are in Hennepin County. They capture and tag 650 deer and then release them. Several months later, they capture another 77 deer and count 13 tagged ones. How many deer are currently in Hennepin County? So, what is known and what is unknown? Unknown is the total number of deer in Hennepin County. Known is out of the total of 77 deer, 13 were tagged. Our variable should be the total number of deer in Hennepin County, since that's what we're trying to find. Our proportion, we are comparing the number of tagged deer to a total number of deer. Our first numerator in this case will be the tagged deer. On the left, it's the tagged deer out of the total population, because we captured 650 out of the total population and tagged them. On the right side, we have the 13 tagged deer out of that second smaller group. Out of these, the total is in the denominator, so the entire population, the total is unknown. In that second group, the total population was 77. Again, it's really important to understand what you're comparing. Notice how I didn't put the units deer in, because in all cases they're deer, and that is not helpful. The key is, in this case, that we're comparing tagged to total. Now we will solve our proportion by multiplying by the common denominator of x times 77. So multiply both sides by x and 77. On the left, the x's cancel. On the right, the 77's cancel. And then 77 times 650 is 50,050, and 13 times x is 13x. Divide both sides by 13, and we get 3,850 equals x. Therefore, the DNR estimates that there are 3,850 deer in Hennepin County. We can check this. In this case, we could use simplifying. The proportion that we would get for tagged total would be 650 over 3,850. If we simplify both of these, we get the fraction 13 over 77. So we know in this case that we did our arithmetic correctly. That doesn't necessarily mean we had our proportion set up. So depending on how you check your answer, in some cases you are checking arithmetic, in other cases you are setting up the proportion. You need to know your area of weakness and use the appropriate check. If you tend to set up the wrong proportion, then one of our other checks from the other problems would be more helpful. If you usually have your proportion set up correctly, but you tend to make an arithmetic error, then you would want to use this form of a check. Again, our answer in this case is that there are 3,850 deer in Hennepin County. That concludes section 6.4. Your next step is to complete the worksheet for section 6.4. This is worksheet 36. Then check the key for worksheet 36 in D2L. Then complete the online homework for section 6.4 through MyMathLab. This is all we will be doing from chapter 6. Your next section is actually section 8.5, and 8.5 is the only section we are covering from that chapter.